Swayam Prabha. Digital India. Educated India.
Hi friends, now we will discuss on the module tutorial on gasification. In this module, we will solve some numerical problems on gasification. The statement of the first problem is a MSW has the following composition on mass basis: C 37.5%, H 8.8%, O 27.6%, N 0.40%, S 0.10%, moisture 20.5% and S 5.1%. Determine the molecular formula and heating value of the MSW using the following relation, that HHV in mJ per kg, that is equal to 0.3516 into C plus 1.16225 into H minus 0.1109 into O plus 0.0628 into N plus 0.10465 into S. If the above waste material is gasified in a fluidized bedded gasifier, what will be the composition of syngas when waste to oxygen ratio is maintained at 0.8 mass by mass and steam to MSW ratio is also maintained at 0.1 mass by mass. Assume CO is to H2 ratio in syngas as 2:1 volume by volume. Ignore the presence of other impurities and consider the molecular weight of the S as 56. Also calculate the yield of hydrogen and CO. Why the CO and H2 content is so low? How it can be improved? So, on the basis of these statements, we have to determine 6 things. So, the first is we have to get the molecular formula of the MSW, then we have to find out the heating value, then we have to calculate the composition of the syngas, fourth we have to calculate the yield of hydrogen and CO, then fifth we have to see what is the CO and H2 content and why it is so low and how it can be improved. To solve this problem, we have to take some basis. So, our basis is equal to say 100 gram of MSW. So, carbon present in this, that is equal to 37.5 gram, as 37.5% is carbon. So, hydrogen present in is equal to 8.8 gram and then oxygen present in it is equal to 27.6 gram and N is equal to 0.40 gram, S is equal to 0.10 gram and moisture is equal to 20.5 gram and S is equal to 5.1 gram. So, total we are getting 100 gram. Now, this 37.5 gram we can convert it into molecules moles. So, that will be 37.5 divided by 12, that is equal to we are getting 3.125 moles and hydrogen will be 8.8 divided by 1, 8.8 moles and then oxygen 27.6 divided by 32. So, it will give us, sorry, this will be 16, oh not 32, this will be 16. So, it is giving 1.725 moles, then nitrogen will be 0.40 divided by 14. So, that is equal to 0.028 and for sulfur this is equal to 0.10 divided by 32. So, that is equal to 0.0031 and for moisture 20.5 divided by 18. So, that is equal to 1.139 moles and for S 5.1 divided by 56. So, that is equal to, it is coming 0.091 moles. So, these are the moles present in the MSW. Now, another thing that the moisture which is present here, this H2 is composed of oxygen and hydrogen. So, we can calculate the oxygen from moisture is equal to 1 mole of H2O is having 1 O. So, we are having 1.139 moles, and hydrogen from moisture is equal to, we are having 1.139 into 2. So, that is equal to 2.2 into 1.139. So, that is equal to 2.278 moles. So, if we want to represent the molecular formula of this material, we are getting that C, that is equal to 3.125 H 8.8 O 1.725 N 0.028 S 0.0031 and S we are getting 0.091 and H2O that is equal to 1.139, or we can write C 3.125 H 8.8 plus this 2.278. So, that is equal to coming 11.078, 11.078. Oxygen similarly 1.725 plus 1.139. So, it is coming 2.864. So, 2.864, N is 0.028, S 0.0031, S 0.91, 0.091. So, this is equal to. So, this is the molecular formula of the waste. So, the first part is complete. The second part we have to determine the heating value. So, heating value HHV is equal to given, HHV equal to given, that is equal to 0.35 16 into C, that is C is the percentage of carbon, then 1.16225 1.16225 into H minus 0.1109 into O plus 0.0628 into N and plus 0.1046 into S. So, this is the formula which is given. Here we can calculate the heating value considering the as received basis or wet basis or dry basis or dry and aspire basis, any basis we can calculate. So, if we want to on wet basis, we will put the value 0.03516 into C. So, that in that case 37.5 plus 1.16225 into 8.8 minus 0.1109 into 27.6 plus 0.0628 into 0.4 plus 0.1046 into 0.1. So, that is equal to around say 20.387. So, 20.387 megajoule per kg. This is on wet basis. Now, we can convert it into dry basis or dry and aspire basis, anyone as you wish. So, dry basis if we want to do, in that case C will be, this will be 37.5 into 100 divided by 100 minus 20.5 minus 5.1. So, this will be on dry and aspire basis. So, it is coming 50.4%. So, 50.4%, dry and aspire basis, it is coming 50.4%. Similarly, the same formula will be used, 8.8 into 100 divided by 100 minus 20.5 minus 5.1. So, it will give us the hydrogen is equal to 11.83%, oxygen will give us 37.10% and nitrogen will be 0.54% and sulfur will be 0.13%. So, if we put this value here in this formula, then we will get the HHB on dry and aspire basis, and that is equal to 27.40 megajoule per kg. Similarly, we can calculate on dry basis. In that case, we will remove the 0.51 from here. So, that will give this only dry basis, not dry and aspire basis. So, any question comes, either the HHB may be asked to determine on dry basis, on wet basis, on dry and aspire basis. So, this way it can be solved. The next part of the problem is that we have to find out the composition of the syngas. So, for the to finding out the composition of the syngas, obviously we need to get some mathematical representation of the reactions. So, some mathematical representation of the reaction is required. So, that is here assume that CaHB OC ND Se as N plus FH2O plus GO2, that is giving us HCO2 plus H2 plus JCO plus D by 2 N plus KSO2 plus MH2O plus NS. So, this is a reactions we are assuming. Now, we have to find out the value of A, B, C, D, E, N, F, G, H, I, J, K, M and N. Then we can get the how much, see if we get the value of H from this much of amount of material, how much CO2 will be produced we can calculate. If we get the value of I, how much hydrogen is produced we can calculate. If we get the J, we can get the moles of CO produced. If we get the K and M value correspondingly SO2 and H2 produced we can calculate. So, that will be our job now. So, if we do the elemental mass balance, so for carbon balance we can write A is equal to 2H, A is equal to H plus not 2H, H plus this H plus J. So, this plus J and A is equal to how much? We have got A is equal to 3.125, 3.125 we are getting here. Next is we will do hydrogen balance. So, left hand side is B plus 2F, right hand side is equal to 2I plus 2M. So, this is for hydrogen balance. If we go for oxygen balance, then we will get C plus F plus 2G, C plus F plus 2G is equal to 2H plus J plus 2K plus M. Now, D is equal to nitrogen balance. So, D is equal to how much? D is equal to 0.028, 0.028 and then E by sulfur valence E is equal to K K and E is what, that is equal to 0.0031, that is 0.0031. Now N is equal to 0.091. Now we have got these values and some relationship. Another condition is given. What is that? CO and H2 ratio in the syngas. CO and H2 ratio in the syngas is given. That ratio is CO is to H2 is equal to 2 is to 1. So, CO is to H2 is equal to 2 into 1. So, one is CO is to H2 is equal to 2 is to 1 in syngas. So, that is giving us that this I and J, this relationship. So, J is equal to 2I, and another is also given mass of MSW by mass of oxygen is 0.8. So, mass of MSW by mass of oxygen is equal to 0.8, it is given in the statement. So, our molecular weight of the MSW, molecular weight or of the MSW will obviously be around 100 gram as we have taken it. So, it is coming 99.8156 gram. Therefore, mass of O2 used per mole of MSW. So, mass of oxygen used per mole of MSW will be mass of O2 used per mole of MSW is equal to 99.8156 divided by 0.8, that is equal to 124.77 gram, that is equal to this 124.77 divided by 32. So, that is equal to 3.899 moles of oxygen. So, oxygen which is used for this MSW, that is equal to 3.899 moles. So, now we have got the value of G. So, we have got the value of G, that is equal to 3.899 moles, and we have got some mathematical expression also. Now, another information is given, that is the steam and MSW ratio. So, mass of steam by mass of MSW is equal to 0.1, mass of steam by mass of MSW is equal to 0.1. So, H2O or steam used during gasification is equal to how much? Used is equal to 0.1 into the 99.8156 gram, that is equal to 9.98156 gram. So, if we convert this in gram into moles, so that will be divided by 18. So, 0.555 moles, 0.555 moles. So, this moles of steam is used. So, now we have got the value of F, that is equal to 0.555 moles. We have also got some expression. Now, from these expressions we have to get the value of I, we have to get the value of H and M. So, we have 3 expressions 1 to 3 and we will get 3 variables. So, we can solve it. So, here we see H plus J is equal to 3.125 and we have got B plus 2F equal to this. So, B is equal to what? B is equal to 11.078. So, B plus 2 into F, F equal to what? 0.555. these two we are getting. So, that is equal to 2I plus 2m. So, this gives us I plus m is equal to this plus this divided by 2. So, that is coming 12.188 divided by 2, that is equal to 6.094. Say we are putting this equal to A, equation A. Another expression we are having C plus A plus 2G. So, what is our C? C is equal to here 2 point that is oxygen content, that is equal to 2.864 plus F is equal to 0.555 and 2G. So, 2 into 3.899. So, this is the left hand side and the right hand side is equal to 2H plus J plus 2K plus M. So, 2K 2 into 0.0031 plus M. And another expression we have here, that is CO by H2 equal to 2 or J equal to 2I. So, J equal to 2I. So, if we put this J equal to 2I here, so this will be equal to 2H plus 2I plus 2 into 0.0031 plus M, that is equal to, we are getting this part is coming equal to 11.217, that part is coming equal to 11.217, or we are getting 2H plus 2I plus M, that is equal to 11.27 minus this 2 into 0.0031. So, that is equal to 11.211. So, we are putting it equal to C, and we have H is equal to H plus J is equal to 3.15. So, H plus J is equal to 3.15. If we put the J equal to 2I, so we can write H plus 2I is equal to 3.15. So, we are putting it equal to B. Now, by using this A, B, C, we can calculate the value of H, I and M. So, minus C by C minus B, so this minus this, if we make C minus B, so 2I will cancel. So, by C minus B we are getting 2H plus 2I plus M minus H minus 2I, that is equal to 11.211 minus 3.15. There H plus M is equal to, this is giving us H plus M is equal to 8.086. So, now we are giving it as equation D. Again by D minus A, we are getting H plus M minus I minus M. So, what is D? H plus M. What is A? I plus M. So, minus I minus M. So, we are getting here this is equal to 8.086 minus 6.094, that is equal to H minus I, that is giving us H minus I, that is equal to 1.994. We are giving an equation E. Now, by 2 into E plus B, if we multiply 2 into B plus E, 2 into E plus B, by 2 into E plus B, it will give us 2H minus 2I and B plus H plus 2I, that is equal to 2 into 1.994 plus 3.15, or H equal to we are getting 2.37. Now we are putting it as F. So now we have E, now we have got F. Then what we will do, putting the value of H in B, which value we are getting here, the value of H which we are getting here, if we put the value of H in B, then we will get the value of I. So 2I, putting the value of H in B, we get 2.37 plus 2I is equal to 3.15, or it is giving I is equal to 0.377. So that is equal to say G, that is equal to G. Now we have got the value of I, we have got the value of H, now we need to get the value of M. So from G and A, from expression G and from expression A, we will put the value of I here and we will get the value of M. So M is equal to, that is equal to 6.094 minus 0.337, it is coming 5.717. So now we have got all the value of I, J, H, M, etc. So on the basis of this value, now we can see the composition of the syngas. So on the basis of this, we can get the value of syngas composition. So what will be the CO2? CO2 is equal to how much? H. So H value is equal to 2.37. So 2.37, and then we will get H2. H2 is equal to 0.377, and then we will get CO. CO is equal to 0.754, and then we will get N2, that is equal to N2 is equal to D by 2. So D is equal to, here we have got 0.0286, so that divided by 2, so 0.0143, and now you are getting SO2. SO2 is equal to 0.0031 moles, and now we are getting H2O is equal to 5.717. So these are the moles which are present in this. So if we get the total moles, so total moles is coming 9.2354 moles. These are the moles. Then we can get the percentage. So we can get the percentage. So if we get the percentage of CO2, that is 2.37 divided by 9.2354 into 100. So it is giving us 25.66%. Similarly for hydrogen, it is coming 0.377 divided by 9.2354 into 100. So it is giving us 4.1%. So 4.1%. Similarly for CO, it is coming 8.2%. For nitrogen, it is coming 0.155%, and for SO2 it is coming 0.034%, and for H2O it is coming 61.90%. The next part of the problem, we have to explain why this CO and H2 is less. Here maximum H2O and CO2 is produced. That means oxidation has taken place. and this is because of the higher oxygen to MSW ratio and also using more steam. So, this is the reason for which we have got less CO and less H2. So, this concentration can be improved by using less H2O and less O2. And the last part, we have to determine the yield of hydrogen and CO. So, yield of hydrogen is hydrogen atom in the syngas by hydrogen atom in the injected, which is being injected. So, hydrogen atom in the syngas is 2I, that is equal to, so hydrogen atom in the syngas is equal to 2 into I, and hydrogen atom in the feed is equal to this B. So, the yield of hydrogen is equal to the 0.754 divided by 11.078. So, that is equal to, it is coming 0.068. Similarly, for CO, the yield is equal to carbon atoms is found in CO divided by carbon atoms injected. So, in this case the yield of CO is equal to J divided by A, and J is equal to 0.754 and A is equal to 3.125. So, it is giving us is equal to 0.241. So, now we have completed all the parts of this problem. So, thank you very much for your patience.